This is the lesson for chapter 8 or lesson 8. I'm not sure which they call them here. We're going to work through the, let's go with blue. We're going to work through the lesson 8 quiz or test together. You will most likely get slightly different problems, but these are going to be the problems that are of most important. So question 1, we're asked to simplify, which we do this by factoring. So we look at the top, there's a 9 that can be factored out, leaving x plus 10. And in the denominator, see if I can, yeah, I like it a little bit. There we go. We can factor this into, and once you get one factor, so x plus 10 is probably a factor, I'm going to say, so we get some canceling. So if x plus 10 is 1, we've got a plus 9, this must be x minus 1. So negative 1 times 10 is negative 10. You get a plus 10x, a minus 1x, which gives you the middle term. So that factors correctly. X times x is x squared. And then what we get is it simplifies, the x plus 10s cancel. So this should be 9 over x minus 1. And we put that in here. In teacher version, I can just click on and find the answers, so that double checks it. Okay, let's go on to 2. So divide and simplify. Now, we're dividing, so that means we invert and multiply. So while we're doing that, let's go ahead and factor as we go. Okay, so we're going to rewrite each of these in factored form, and then we will sort of simplify as we divide. Okay, so let's look at the bottom, because sometimes that's helpful. So x squared minus 4 is a difference of squares. 4 is 2 squared, so it does factor into x plus 2, x minus 2. X squared minus 36 is also a difference of squares. It's going to be in the top, right? Because when we divide, we flip and then turn it to multiplication. So I'm going to put the x squared minus 36 up here, but that's going to be an x plus 6 times an x minus 6. Okay. Now this one in the numerator, we're kind of back here. So this part is, we're going to factor and put it here. So we got a minus 16, a plus 6. Let's see. 16 is 4 times 4, but you won't get a middle term. How about 2 times 8? And if you take 2 minus 8, you get 6. So that's what's going to work. So we're going to get x and x. To get the 16, we've got the 2 and the 8. Since we have a plus 6, the bigger one is positive. The smaller one would be negative, so that we get the negative 16. Okay, and we can sort of see as we're going here, x minus 2 and x minus 2 will divide out, become 1. So we're simplifying as we go. Let's take this numerator here, and it's going to be down here in the denominator because we're flipping. So 48 is 8 times 8 times 6, right? 6 times 8. 6 plus 8 is 14. Okay, that's going to work. So we've got x times x. 48 is going to be 6 times 8, so we've got our 6 and our 8 here. This means they're going to have the same sign, and this means that they're both positive. So 6 times 8 is 48. We get 8x plus 6x gives us 14. So that's all good. And we see a little bit of canceling. X plus 6 and x plus 6 go away. Whoa. And then crosswise, basically when we multiply, right, we just make it one big fraction and everything is being multiplied. X plus 8 and x plus 8. So all that's left as we go through is x minus 6 over x plus 2. Okay, and all I'm going to do, instead of rewriting this, there's the x minus 6, there's the x plus 2. Okay, so that's how we do a division problem that asks us to simplify. Simplify the complex fraction. This is really the same thing. This is the top fraction divided by the bottom fraction. So we're going to rewrite that as x, and since we're going to simplify, we'll factor as we go. So x squared minus 36 is a difference of squares, so that's going to be x plus 6. 36 is 6 times 6 times x minus 6. Okay, and then we're going to multiply by the reciprocal of the denominator. So the 9 will go in the denominator, and then the x minus 6 goes in the numerator. Okay, and then again, when we multiply two fractions, we multiply straight across. So go like this. Everything is getting multiplied. X minus 6 can cancel with x minus 6. So what we have in the numerator is x. And what we have in the denominator is x plus 6 times 9. Let's just see if they leave it. I think they're going to distribute that out. Let me kind of, just to make it nice, so it would be 9x plus 54, right? 6 times 9. Let's see what they do. Oh, they left it factored. I like that. I would actually prefer to leave it factored. So both of them should get counted correctly, but again, yeah, x over 9 times x plus 6. Why should we do all this extra work, right? Okay, so that's good. Question 4. We're asked to simplify this expression. So we're getting a fraction, right? And they want the numerator and the denominator, right? So that's f of x will be the numerator, g of x will be the denominator. When we're going to add or subtract fractions, we need a common denominator. So to do this one, we see what our denominator is here and here. Basically, we need to multiply the first one times x plus 8 and multiply the second one times x plus 5. So let's write this. This is what we have. Let me move it up, make sure I have enough room. So what we have is 1 over x plus 5, and we're going to subtract 1 over x plus 8. We are going to multiply the first one. We'll put a parentheses there. X plus 8 and x plus 8 here. Okay, and the second one, put this, we're going to multiply by x plus 5. X plus 5 in the top. And notice x plus 5 divided by x plus 5 is 1, so we are just multiplying by the number 1, which doesn't change a number. Over here, x plus 8 over x plus 8, that's also 1, so we're not going to change anything. It'll look different, but it's a valid way to do this. Okay, so then in the numerator, we get x plus 8 over x plus 8, x plus 5. we subtract x plus 5 over x plus 8 times x plus 5. So now that they have a common denominator, we can write them as one fraction. We get the x plus 8 here. When we're subtracting, we need to distribute this to both of the terms, right? Because it's kind of like that. So we get a minus x minus 5. Most people will miss this minus on the 5. They'll put it on the x, but they forget to put it on the 5. Combine like terms, x minus x, that's 0. So it's like cancel each other out. 8 minus 5 gives us 3. And then in the denominator, we get x plus 8 times x plus 5. So f, this front one, should just be 3. And that's what it is. The bottom one should be x plus 8 times x plus 5, and that's what it is. Again, it's commutative, so you could have it in this order as well. It won't matter. It's the same. All right, looking good so far. So that's question 4. Question 5 is very similar, common denominator, but to get to that, we're going to need to factor the denominators and then see what's missing or needed. Okay, so we're going to go with the first fraction, and we're going to factor this. Looks like 3 is 3 times 3 plus 3 is 3 times 1. 1 plus 3 is 4. So this one will factor into x and x. 3 is 1 times 3. We have this plus, which means they're the same sign. This plus, which means they're both positive. If it was negative, they'd both be negative. So that's factored there. Then we're going to subtract 1 over, let's factor 5 is 5 times 1. But with the negative, it means we're subtracting. 5 minus 1 is 4. Okay, so we come here, we get our x times x is x squared. 1 times 5 is 5. We know this means the signs are opposite. One's positive, one's negative. This, since it's negative, means the larger one is negative. Okay, so we go through that. Now, as far as common denominators, they both have an x plus 1, so they don't need that again. This one needs an x minus 5. So we'll multiply by that, but if we do that to the denominator, we have to do it to the numerator. The second one is missing an x plus 3, so we'll go ahead and multiply by x plus 3, and an x plus 3 in the numerator. Again, we're multiplying by a form of 1, so multiply by 1, nothing happens. And so now I'm going to kind of shorten the steps here. We'll have an x minus 5 here, times 1, right, and an x plus 3. So we will have the common denominator of x plus 1 x plus 3 and x minus 5. In the numerator, we will get x minus 5. And again, I'll do this as a step. This negative has to distribute to both, so we get a minus x minus 3. X minus x is 0. In the numerator, negative 5 minus 3, that's going to leave us with negative 8. And instead of rewriting it, this is what our denominator is. Again, we'll just check it here, negative 8. And there's our denominator, just like we said. All right. Step it up another notch. Again, this is a complex fraction. It really is just division. But we've got 2 plus 20 over a, so we've got sort of a complex fraction within a fraction. One technique that works for this is if we multiply by the common denominator, we will get rid of these denominators. Okay, so we see a common denominator is a squared, right? That will get rid of both the a and the a squared. So this is a times a, the bottom, the top part is a. So what we're going to do is we're going to multiply the top by a squared and the bottom by a squared. And notice that is just a form of 1. But each of these are grouped, so when we multiply through, I'm going to go up a little bit higher, this has to distribute to both of these terms. So a squared times 2 is 2a squared. A squared times 20a, let me do that over here. This a cancels with one of the a's, right? So this is now just a to the first, so this is going to be 20a. So it's 2 plus 20. Let me stick with the same colors, I guess. 2 plus 20a. But notice the fraction is gone from the top. In the bottom, we're going to have a squared, which is going to distribute. A squared times 1 is a squared. And then when we multiply this by a squared, hopefully you can see that a squared cancels with the a squared, so then you have minus 100. Simplify completely. So now let's see, we could factor, right? In the numerator, there's a 2 that, actually a 2a that comes out. 2a. And if you take a 2a out, you're left with a, right? Because 2a times a is 2a squared. And here, 2 comes out, so that's a 10. And a came out, so that's just a 10. So a plus 10. In the denominator, this is a difference of squares. A squared minus 100. 100 is 10 squared. So this is going to be a plus 10 over a minus 10. And oftentimes, if you can factor 1, so maybe it was easier to see the numerator, a plus 10. If this is going to simplify, you'll see an a plus 10 in the denominator, which we do. So sometimes that's you get these little hints. So go for the one that's easiest to factor for you, and then use what you end up with to say maybe, not always, but maybe the bottom might factor. One of those factors is down there. And yes, a plus 10 cancels out. It's a factor of 1. So we have 2a over a minus 10. And that should be our answer. So in the numerator, we're left with just 2a. In the denominator, we're left with a minus 10. Perfect. We got it. Okay. Question 7. Now this is one where we can use cross multiplication. There is a factor whenever two fractions are equal. Let's use one that's not too hard. If we cross multiply, because that's what it's saying, they're equal, or multiply by the reciprocal. Multiple ways to do this, but this will work out. We're able to solve 3 times 16 is 48. 3 times 6 is 18. Yeah, 48. And then 4 times x is 4x. And notice, since 16 times 4, 4 times 4 is 16, 3 times 4 should be what we get here. X should be 3 times 4. And I believe we get there. So we divide both sides by 4, and you get x equals 12, which 3 times 4 is 12. Okay, so that all works. So this is just to show the technique we're going to use, or could use. I would use it. So I'm going to cross multiply. So this is 1 times x plus 1 equals x plus 2 times negative 5. And I'll do this in 2 steps just so we can see it. So I have to distribute. Now, I could distribute the 1, but that doesn't do much, right? So we're going to distribute here. We get x plus 1 equals negative 5x minus 10. Add 5x to both sides. Just to keep things positive, we could have subtracted x from so we get 6x plus 1 equals negative 10. Now solving for x, let's subtract 1. And so we get 6x equals negative 11. Divide by 6. X equals negative 11/6. Negative 11/6. Okay. All right. Number 8. And again, if you go through and you see how to do it, you can fast forward to the next question, but we'll just keep working through each of these questions. Now this one, the easiest way is to use our technique of multiplying by the common denominator to clear out the denominators. But to kind of get the common denominator, it's also helpful to factor, because we can see like this one is going to factor into 3 times x plus 1, factoring out the 3. So we see a common of x plus 1 here. We see a 2 and we see a 3. So we need to multiply. The common denominator is going to be 2 times 3 times x plus 1, or 6 times x plus 1. We're going to leave it this way, just make it maybe a little easier. Okay, so this first fraction it's already got the x plus 1, so it needs the 2 times 3. 2 times 3 is 6, so I'll multiply by 6 over 6. Okay, then we got a minus. Now 3 halves, it's got the 2, so it needs the 3x plus 1. In fact, just for consistency, let me change the color. It should be 6 over 6, so that's what I'm multiplying by. And then change back to the blue. I'm going to multiply 3 over 2. So that's the fraction we had. We'll do the multiplication to get the common denominator. If I can get this I can't really get any higher, so I'll go lower. And then that's going to be equal to 6 over 3. Wait a minute. I'm not doing the right thing. But I'm not far off. This would get us a common denominator. So this is an approach I've seen used, but a better approach is to multiply each of these by sort of 1 over the common denominator. So let me do it this way. So I'm going to multiply this by 2. And this works because we have an equation, and so we can multiply both sides by the same thing is what we're doing. So it's a little different than multiplying everything by 1. We're multiplying both sides of an equation by the same thing. Okay, and the reason we're going to do this, you're going to see we'll be left with no fractions. Because when we multiply we get some canceling here. X plus 1 divided by x plus 1 is 1. We get 2 times 3, which is 6, times 5, which is 30. Here, the 2's are going to cancel, and we're left with 3 times 3, which is 9 times x plus 1. Okay, so these parts multiply. And then over here, 3 cancels with 3, x plus 1 cancels with x plus 1, and we're just left with 6 times 2, which is 12. Now we have a linear equation left to solve, and then we're in good shape. So this will be, let's go ahead and distribute the 9. That'll be negative 9x minus 9. Here's our 30 out here, equals 12. 30 minus 9 is 21. So we get a plus 21. Let's see, let's subtract 21 from both sides. Negative 9x equals negative 9. Oh, that's kind of nice. And then divide by negative 9. All of that means that x equals positive 1. Wow. And you could maybe, if you plugged in positive 1 back up here, 1 plus 1 is 2, 5 halves, minus 3 halves, that's going to be 2 halves. If you put in a 1 here, you get 3 plus 3, which is 6, which is 1. 2 over 2 is 1. 1 equals 1. It checks. Okay, cool. So 1 is our answer. And we'll just do a quick check here. Yeah. 9 will be a similar type thing. We want to multiply by the common denominator. And then we've got 10. So we're almost there to the end. Only thing is I used up much of my space here. So let me erase this lower part here. And we'll do one more example of multiplying by the common denominator. So first of all, I'm going to factor. So this is one factor. This is the other factor. And wouldn't it be nice if this was x minus 1 times x plus 3? And I think we're going to see it is. 3 is 1 times 3. The larger, and they have different signs. So we got x and 3, x and 1. This tells us that the signs are different because we're going to subtract. This plus tells us that the bigger number is positive, smaller number is negative. So yes, it all works out. So what we want to multiply both sides by is x plus 3 times x minus 1. So let's come up here and rewrite it. We get x plus 1 in the numerator, x minus 1. So I'm just rewriting that first term. I'm going to put parentheses around just so we know what's happening. And what we're going to do is we're going to multiply this one, x plus 3 times x minus 1. We're actually multiplying this whole side by that, and we'll see it hits here and then it distributes. Oh, actually, we got our equal sign here. So then we get equals. We're going to do the same thing with this negative 10. So I'm going to move it over a little bit. This is negative 10 over x plus 3. We're going to multiply that because we're doing this, multiplying both sides by the same thing. X minus 1. And then we've got this plus. I'll do it over. Oops. Just keep seeing colors. We've got this 8 in the numerator. X plus 3. We can put some parentheses around each of these. X minus 1. And then we're multiplying because when we multiply a side, it distributes to all the terms. X plus 3, x minus 1. And so we'll switch to green. Over on this first term, x minus 1 goes into x minus 1. That's 1. So we're left with x plus 3 times x plus 1. Over on the right side of the equal sign, x plus 3 cancels with x plus 3. So we have negative 10. While we're at it, I'm going to distribute that. I think is probably a good idea. So negative 10 times x, negative 10x, negative 10 times 1, positive 10. Here, x plus 3 and x plus 3 cancel, x minus 1 and x minus, we're just left with 8 plus 8. Okay. And they want us to solve the equation, which means x equals, right? So let's FOIL this side out. And it's sort of like, okay, it's what we had here, right? X squared plus 2x minus 3 equals negative 10x plus, let's go ahead and combine this to 18. Now, if we have a quadratic, generally what we do is we get everything to one side and 0 on the other. So let's go ahead and add 10x and subtract 18 at the same time. So we're going to add 10x and we're going to subtract 18. The reason we do that is quadratics, the best one, well, is if we get a quadratic equal to 0, they're easier to solve. So we get x squared plus 12x minus, that looks what, 21. 21 is, it could be 7 times 3. Is this thing going to factor? It might not factor, which would make it not work out too good. Let's see, 7 times 3. There's negative, you're not going to get 12 subtracting it. That's another thing that's, but that's it. Maybe that, well, let me just check my answer in advance. It looks like we're going to need to go, we're going to need to use the quadratic formula because this doesn't factor in this form, unless I've made an error here, which is always possible. Oh, wait. Oh, yeah, I was too fast. This is x plus 1, not x minus 1. Okay. Sometimes you just get yourself going too fast. Okay, you see where I made my error is I went with this thing, but I've got an x plus 1. I need to fix this. Okay, so let's back up. This isn't, well, we'll be doing that, but this multiplies into something different. Not too far off, but 3 times 1 is 3. And it's going to be a positive 3. And then we're going to get 1x and 3x, so we get a 4x. Let me just rewrite this. Plus 4. Plus 4x plus 3. 3 times 1. Now, it's not always this case. I mean, doesn't mean they have to factor, but in this case, it's kind of nice. So now we add 10x, subtract 18. This is the right thing to do. Add 10x, subtract 18. We're going to get a different result, and I believe one that will factor. This is 14. And this, 3 from that is going to be 15. And it's going to be negative. And equals 0. 1 times 15 is 15. And when you subtract 15, 1 minus 15, you get 14. Okay, so it tells us it's going to factor into x and x, 1 and 15. This tells us that the signs are opposite because we're going to subtract. This tells us that the bigger number has the plus, so the smaller number must have the minus. So to solve this, we get x minus 1 equals 0, or x plus 15 equals 0. Add 1 to both sides. X equals positive 1. Subtract 15 from both sides. X equals negative 15. So those are our two. Let's separate them by commas. So we would just put in 1 comma negative 15, or the other way around. And I think we're good. Oh, they only get negative 15. Well, valid solution. Oh, okay. One thing we always have to check back here. Valid solutions. If I put in 1, kind of tricky on this, up here, I'd get division by 0. So that's why 1 is what's called an extraneous solution. So I want to say, yes, I do get x equals 1, but it doesn't work because it would make the original undefined. Okay, so let's come back here. We do have to do that. Valid solutions. All right. Sometimes we just go too fast. At least I do. Okay, so let's come to this last question. Hannah can paint a room in 10 hours. Destiny can paint the same room in 6 hours. How long does it take for both Hannah and Destiny to paint the room? I think this is supposed to be if they are working together. Little typo. Enter the exact time as an improper fraction if needed. So they can paint a room in 10 hours. So in 1 hour, how much of the room will Hannah do? In 1 hour, she will have done 1/10 of the room. And then Destiny in 1 hour will have done 1/6 of the room. And so we can say in any given, what about in 2 hours? Well, 1/10 times 2. So what we do is we say T is equal to the number of hours, right? So however many hours it takes to do a job, Hannah will do 1/10 of those hours times T. Since they're working together, she's got a helper, and that's Destiny. She will do 1/6 of the job each hour. So whatever T is, we add those together, and that means that one job is going to be done. It's been a while since I've done these, and I'm just coming off the cuff, but I think that's what it is. They're going to complete one job. So working alone, you can see Destiny T would be 10. 10 over 10 equals 1. Destiny would need 6 hours, 6 over 6, so Destiny's a little bit faster. But working together, they will still just get one job done. Okay, and so the technique we use for this one, we could get a common denominator, but again, we can also just multiply both sides by the common denominator, which is 10 times, well, not necessarily have to be 10 times 6. It's 10 is 2 times 5, right? 6 is 2 times 3. So the common denominator is going to have a 2, a 3, and a 5. So the lowest common denominator will be 30. Okay, but what I'm going to do, I'm going to say I didn't know how to find the lowest common denominator. I'm going to show you. Since we've got an equation, it will all simplify in the end. Let's just use a common denominator, which is 10 times 60. So I'm going to multiply, 10 times 6, which is 60. So I'm going to multiply this by 60, this by 60, and this by 60. Because it's an equation, I've multiplied both sides by 60. Over here, 10 goes into 60 6 times. I have 6 times 1. 6 goes into 60 10 times, so I have 10 times 1. So I end up with 6t plus 10t equals 60. That says that 16t equals 60. Divide both sides by 16. T equals 60 over 16. Now had I used 30 instead of 60, the lowest common denominator, I probably wouldn't have to reduce over here. But I can see, okay, let's see, will 4 go into both of these? 2 goes into both, so that gives me 30. 6 divided by 2. 16 divided by 2 is 8. Oh, we can keep going. 2 will still go into both of this. That's 15. And 2 goes into 8 4 times. And I think that's going to get us to our lowest common. So even if we use 30, we would have had to reduce. So 15 over 4 hours as an improper fraction, which is that's 3 hours and something. 3 hours and 70.75, which is 3 hours and 45 minutes. 15 force hours. Okay, submit it, we're done. Okay, so that's your quiz or your test. It should help you with the homework as well with those various techniques. Thank you all. And let's see, how do I finish my recording?